Good morning. This is Union Session 52A on climate confluence issues, energy, environment, economics, and security. These presentations will be on the video on demand, so they're being filmed. I'm Don Webbles. I'm University of Illinois and one of the co-conveners along with John Reisman, who will also be a speaker. What we're going to do is we're going to have four ostensibly 15-minute talks. And then after that we'll have a panel discussion. There is one issue, though, in that Guy Brasseur needs to leave for the airport at around 11 o'clock. So what we're going to do is move him up into the second slot. Our Navy representative actually dropped out, but John Reisman is going to give a few slides about the Navy perspective on security issues related to climate. And so we'll move Guy up, and if you have any particular questions for Guy before he leaves, we'll ask for them then. Our first speaker is Chris Field from Stanford, and Chris is going to talk about ecosystems and food security in a changing climate. Chris. And we need to switch this over. There's the keyboard. I need to up this on here. So, you got it?
I think so. Good morning, everyone, and thanks for coming to a series of presentations that are on kind of big picture interdisciplinary issues. It's really tough to get your arms around some of these issues that are among the most important ones we have to deal with as scientists, and I admire the initiative to come, especially on the last day of the meeting. What I want to talk about today is really two relatively simple issues. The first is what's the nature of risk and the risk associated with climate change? How does thinking about climate change as a risk management problem change things from thinking about as a purely scientific problem? And the other thing I want to review really quickly is the question of whether there appear to be thresholds in the responses of two important parts of the Earth system, the way ecosystems respond to climate change and the way that food systems respond to climate change. I think the frustrating answer for the future of the world is that there do appear to be thresholds, but the thresholds are very difficult to get a handle on, and they involve processes with a level of complication that's been very difficult to model. Let me start with risk. In the formal sense, the best way to think about risk is as the product of the probability of some event happening and its consequences. And if we think about that in a formal sense, we have some probability distribution associated with an event. And for most of the kinds of events that are associated with climate impacts, there would be increasing impacts as the event gets to be larger and larger. So just nominally, I've drawn an exponential increase in the consequences. And if we look at the product of those two, we get a shifted distribution that reflects the risk. And the critical thing about the risk, it's the green curve before you, is that the area of most importance is shifted to the right, to the higher consequences from the most likely outcome based on the climate science. In climate science, we typically have tried to provide an accurate assessment of where the most likely outcome is and to provide some sense of what the high and low limits of the possible outcomes are. But we've done very little to really try and characterize risks. We've done very little to say what are the consequences as we move into the lower probability, higher consequence part of the domain that's very likely to influence the serious part of risk management for a wide range of climate events. And we also haven't done a very good job of just characterizing what the overall levels of risk are. Of course, one of the consequences of thinking of climate change as a problem in risk management is that knowing less is typically not a motivation for doing less. In fact, if we think about the distributions that I'm showing here on the screen, where we actually have a greater range of uncertainty about the climate outcome, the risk actually gets to be much greater as a consequence of the greater uncertainty multiplying with the exponentially increasing consequence. We actually should be doing more about the events that we do know less about, at least in this context. So in this framing of risk management, let me talk about a series of things I think about as special challenges of ecosystem and food security, although when we look across the universe of climate impacts, I think what we see is that these features are common to a very broad range of impacts. The first is that the climate influences can be important, but they're rarely the only factor that's making a big difference. In many cases, there are many factors, some of which are under human influence, some of which are not, some of which are well understood, some of which are not, and some of which have their greatest influences through interactions that are difficult to characterize. A second important feature of ecosystem and food security issues is that the patterns are highly diverse spatially and temporally. Their controls vary from place to place, and the stresses vary from place to place. Critically important feature of ecosystem and food security is that the models are really incomplete. And we do a pretty good job on tracking the energy and the carbon and the water, but we do a much worse job of tracking things like disturbances, multi-trophic interactions when an insect or a pest is involved. And we don't have a very powerful way to understand the consequences of history in almost all cases. A fourth special feature is the one that I want to focus on today, the potential for threshold responses. It's easy to be in a situation where we think things are going along fine or where we understand the fundamental controls and then have the system all of a sudden change behavior in a critically and functionally important way. A fifth feature that's important about ecosystem and food security responses is that as we think about trying to do risk management, we're really hamstrung by the fact that in most cases, even the uncertainties aren't very well known. We may have a decent idea of the central tendency. We may even have a decent idea of the possible range of outcomes, but it's relatively rare that we have a rich understanding of what that probability density function of the uncertainties looks like. And then a final, I would say, very sobering consequence of ecosystem and food security issues is that many of the impacts are potentially permanent. And this is true in a multi-century timescale for climate feedbacks from ecosystem responses, but I think it's true in an even more sobering sense when we begin to look at biodiversity responses where, at least as far as we know, once a species is extinct, it's extinct forever. In the context of risk management, typically the smartest thing to do was to look for low-risk options, things that pay off in the short run, that pay off in the context of a wide range of stresses, and where you can have high confidence that you get additional benefits beyond those that are simply related to the climate changes. And the set of low regrets, low risk options is typically to take whatever common sense actions we can do to minimize the amount of climate change that occurs, to be very careful about the other stressors and release pressure on the system whenever possible, to intervene when necessary. And I think that we're entering a new era in ecosystem ecology that I'm going to refer to as intervention ecology, where we're not simply watching ecosystems change through time, but we're really intervening in a thoughtful and directed way. It's also critical, of course, that we recognize that in the context of incomplete information, learning by doing is a really critical component of making progress. And then finally, we need to respond to that learning by doing by adjusting course and taking advantage of the learning that we do. When we look at ecosystem security, I see the ecosystem consequences is really responding to three very big picture issues, and depending on where you are, any one of these could be the most important, and the importance shifts through time. Probably for ecosystem processes now, the biggest historical change has been due to land use and land cover, with climate change, including changes in the composition of the atmosphere, playing a secondary role. But for many kinds of issues, and I think increasingly in the future, we're seeing the influence of non-native invasive species really beginning to play a pervasive and in some cases a dominant role. At least for me, when we talk about ecosystem security, there are three domains that we want to consider. The first is climate feedbacks, in particular loss of carbon to the atmosphere, where ecosystems contain several times as much carbon as the atmosphere and have the potential to really take control of future climate changes. The second is an area we might call ecosystem services that influences things like climate, but also things like influences on water quality, soil erosion, air quality, habitat aesthetics. And then the final one is biological diversity. And, you know, in the climate community, we've had a really challenging time getting our arms around the biodiversity issue because each species seems to have a separate story, separate controls, and separate challenges. I want to just make a few comments about the evidence for threshold responses in ecosystems. This is a map of the expected % change in fire risk is associated with a 1 degree warming over much of the West. And what you can see is dramatic increases in fire risk, in some cases a 400% increase in projected area burned for each 1 degree of warming, really indicating that for many Western ecosystems, they're right on the edge of whether you have a forest or not a forest as a consequence of disturbance from fire. If we look across all ecosystems, I think we're seeing really 4 major kinds of patterns as reflected in the 4 organisms that you see here. The bay checkerspot butterfly is a locally endangered species from this part of the world. It's extinct from much of its original habitat. And what we know is that it's relatively good at moving, but that the places that it should be moving to aren't available. Land use changes basically eliminated those. The second species there, the yellow star thistle, is incredibly good at moving. It's representative of a group of organisms that are essentially specialists in moving around. It's the most CO2 sensitive species we've ever studied in my lab, and I think it's probably the archetype of the kind of species that can take advantage of the opportunities that are created in the spaces left by climate change and human impacts on ecosystem. At the right-hand side of the figure, you see a sequoia redwood. This is a species that's likely to be able to persist through substantial amounts of climate change. It may have been out of its preferred habitat for a millennium already, but there's a very strong sense in which already it may be a museum ecosystem, not one that's reproducing and succeeding in a sustainable way, but simply hanging on. And then at the lower left, you see what I think is very typical of world forest ecosystems now, a stand of aspens that died as a consequence of drought stress, and we're seeing a very large number of species that are subject to catastrophic mortality events. Trees that we thought had the potential to live for centuries and would probably hang on like the Sierra redwood are dying in mass, and we've seen that with aspens in much of the U.S. We've seen it with conifers in British Columbia, with junipers in the southwest U.S., and species around the world. Basically, I think this large-scale mortality is the nonlinear trigger event for changes in forest ecosystems. The final thing I want to say about ecosystem security concerns extinctions, and this figure is from a 2011 paper by Barnowski and colleague asking whether or not we've entered the 6th major extinction era. And what you can see from this, a mass extinction is 75% extinction, the vertical black line. And the issue is, are we there, or are we moving toward there? And if you look at the number of observed extinctions for a bunch of different biological groups, you can see that not very many species have disappeared. That's the data in the white. But if you look at species that are listed as threatened by the IUCN, you see that it's a very large fraction of species. In some cases, more than 50% of the species are listed as threatened. And at least to me, that raises a great alarm in the risk space that we are potentially headed for a mass extinction event. And that's the kind of a non-linearity that for me poses special, extreme concerns. I want to turn now to the question of food security. And food security is even more complicated than ecosystem security because there are really 4 gigantic pressures on the food system. The first is growing populations. Second is climate change. The third is really, really important, is this dramatic increase in preference for meat-based diets in countries with rapidly developing economies. And then the fourth is emphasis on biomass energy. Using biomass as a way to address climate change has the potential to put grave pressure on the food system. It's clear that we've already seen impacts of climate change on productivity of some major crop systems. This is from a paper that David Lobel and I did a few years ago that presented what I think of as sort of a linear view of climate change impacts, showing that we're looking at something like a 10% decrease in yield for each 1 degree of warming for important crops, including maize, sorghum, and barley. But now I understand that this kind of result was strongly conditioned by limitations on the data that were available. And as we get sufficient data to look in detail at crop after crop, we're seeing not this kind of linear picture, but a much more nonlinear picture, as illustrated in this 2009 figure from Schlenker and Roberts, where you can see for corn, there's essentially no response. This is for the U.S. to increasing temperatures up to, it's about 29 C, and after 29 C, basically the bottom falls out, and you see profound losses where a single day at 40 degrees rather than 29 can represent a yield loss of something like 7%. Even in Africa, now we can see that from field trials in 2011 paper by David Lobel and colleagues. If you look at the consequence of increasing by 1 growing degree day between 8 and 30 degrees, there's essentially no impact on maize yields. But if you add 1 growing degree day above 30 degrees, you see a profound impact. And the consequence here is that adding 1 degree throughout the season results in something like a 20 to 30% yield decrease. Really profound nonlinearity in the system, and I think, at least for me, that represents the essence of the risk that we need to deal with. I want to close with 2 comments. The first is that in response to this increasing evidence of nonlinearity, what are we seeing in response to investments? And in the bottom figure there, you can see growth in agricultural R&D going down and down and down through time. We haven't responded, and the obvious thing we should be doing is focusing more on ag R&D. So finally, let me just say that in all these cases, I think there's compelling evidence for threshold-type responses, and there's compelling evidence that if we think of them in the context of risk management, we really ought to be taking a different approach than we're taking now. We ought to be recognizing that the nonlinear responses are putting the whole system at risk in a way that's very difficult to characterize, but where there are opportunities for actions that hold us away from where these thresholds appear to be. And at least for me, these are strongly conditioned by the fact that in both ecosystems and food securities, we're looking at impacts that persist over such a long period of time. Thanks very much, and I look forward to questions following all the talks.
So unless there's a very urgent question, we'll save the questions till after the talks. The next speaker is Guy Brasseur. As I said earlier, the U.S. Navy speaker is not here, and John will give some slides from that following Guy's talk. Guy's going to talk about projected climate changes and regional security. You're also in the PC? PC. Can you switch it over? We need to turn that. Go find your slides. There you go.
Thank you, Dan, and good morning. I would like to bring to the discussion today some element that link basically some climate projection that are based on global and regional climate models with a number of considerations about security. And I'll give a few examples, one of them being migration associated with climate change. In fact, I'm going to refer very much to a report being now much of the time in Europe, a report that was developed by a group in Germany called WGBU, and let me see here, and just go through a number of recommendations that they have been making to policymakers, because they, I think, deserve some discussion. Let's start with models and models projection. We know that, of course, the climate of tomorrow will be very different than the climate today, depending very much, of course, on the scenarios. On the right-hand side, you see some projection based on the three latest scenarios that IPCC is using. But more importantly are the response of the system from the precipitation point of view. And you see on the left-hand side that the regions that are already somewhat dry will become drier, and the regions that are perhaps wet will get wetter. Don, before I go on, I think we need to put this, because the time is, it's blinking, and yeah, and I'm not sure. I need a time marker. I can stop if you want. Okay, so let's look in more detail, because as we start thinking of the consequence of this warming and change in the precipitation patterns, we also have to recognize that the Earth responds in a very non-linear way with threshold. We just heard some good example of threshold with ecosystem and the food system. They also threshold in the physical system with regions where kind of a flip-flop could happen, another state could happen. And so we need to, of course, identify where those hotspots are located. But if we took, for example, a regional prediction here based on an earlier IPCC scenario, we see, for example, that in Southern Europe, Spain, Italy, Greece, and in Northern Africa, Morocco, Tunisia, Libya, and so on, drought will become a real issue, and the lack of water will become a real issue, and that won't be without consequences on how the population will react. And I'll show some of that. Of course, we have to look at a number of key impacts associated with climate change, and IPCC has listed some here on water, ecosystem, food, coast, health. We just heard some interesting aspect on ecosystem and food. Now, looking at the system as a whole, I think is a way in which the climate community needs to evolve. There's been a lot of modeling activity going on, but today it's interesting not only to look at those important variables, but also to look, of course, where the major threats are and how the risk could be becoming a reality for society. And this shows you again the approach that need to be increasingly taken, where we have to recognize that, of course, climate is one driver of the changes, but it has to be looked at into a multi-driver, multi-stressor aspect, with the climate aspect, the ecosystem aspect, the human health aspect, and the economic aspect. And so when you look at the proportion of people affected by climate-related disaster, for example, you see, in addition to what I just said, that, of course, not everybody is at the same level of risk. And in particular, the people in developing countries are facing risks that are substantially higher than society that are able to adapt to a certain degree to the expected changes in the future. And of course, as I said, we have to look at the problem in a broad sense with different aspects and really try to see what is going to affect prosperity and sustainability for the future. And so, of course, we have been talking a lot about mitigation, and mitigation is a very important aspect. But if you look carefully at what the models tell you, you see that if you want to keep the planet's warming below a 2 degrees value, as stated by the chief of state in the G conferences that happens all over the world, you will need to keep the level of CO2 below about 450 ppm, which requires very rapidly a decrease in the emissions of about 80%. And you can ask yourself, even if this is a real valuable goal that should probably be maintained, is that technically feasible? Is that politically feasible? And of course, perhaps in addition, we have to get ready for other measures if we don't, in particular, limit the climate change to that level of 2 degrees. And that leads us, of course, to issue related to adaptation. And I'm coming to the report that was published in Germany that I think came up with a number of issues associated with security. The report basically says that without resolute counteraction, climate change will overstretch many society adaptive capacity. This could result in destabilization and violence, jeopardizing national and international security to a new degree. It could trigger conflict over distribution of resources, the management of migration and compensation from the countries responsible for climate change. So this report identifies essentially 6 threats. Possible increase in the number of weak and fragile states as a result of climate change. I showed you in particular that the vulnerability of developing countries was much higher than other parts of the world. There are risks for economic development and, of course, regional water scarcity. You saw the graph I showed you, but in addition, soil degradation, more frequent extreme events, impact on industrial side and impact on infrastructure. There are risks of growing international conflict between main drivers of climate change and the most affected countries. There are risks to human rights and that the industrialized country be seen responsible for what's happening and therefore seen their legitimacy as global governance actor be questioned. The risk of triggering and intensification of migration. And of course, it could overstretch the classic security policy by creating conflicts that are more diffuse and really difficult to address. And this shows you, for example, how natural resources could be scarce and where are the hotspots for potential conflicts in the future. In fact, if you look at where the highest emissions of CO2 per capita takes place, you see the countries here in gray. If you're on the other side, you see where the highest social and agroeconomic vulnerability is. You see that these countries are in the tropic, essentially. Putting those two together, they do not match. They are different, and that could create, of course, some tension. You see also here the areas with highest ecological vulnerability. So the world is prone to some kind of new type of tension here that could exist. And in fact, if you look at different impacts, drought, food, storms, sea level rise, impact on agriculture, you see that some countries have already are already witnessing some impacts, and of course some are in the low income range. So how to address the problem, what should be done? And I'm going back to the report of WGBU in Germany saying, well, shaping, first of all, the global political change issue by a constructive participation of emerging nations and developing of a multinational order. The proposal is also to look at how the UN function, and in particular looking at the role of the UN Security Council in these issues, upgrading the United Nations Environmental Programme and strengthening the UN development capacity. Pursuing also a real international climate policy. The report suggests that the 2 degrees guardrail that I mentioned should be kept as a standard, and asking to gear the Kyoto Protocol towards a longer term, somewhat different, of course, conserving natural carbon stocks in particular. Implementing the energy turnaround, improving energy policy, triggering an efficiency revolution, expanding renewable, developing mitigation strategy through partnership, establishing climate protection as a cross-cutting theme in development, and cooperation, agreeing on decarbonization partnership with newly industrialized country, supporting adaptation strategy for developing country in particular, in here adapting water resources management to climate change, avoiding water crisis, gearing agriculture to climate change, strengthening disaster prevention, stabilizing fragile states that are additionally threatened by climate change, managing migration, for example, and here just to show you a bit, a few points about migration. You see here how people are affected by flood and drought in Northern Africa. I'm going to pass this, but really, as you look at migration, you really need to look at it in a very broad context. Climate is, of course, one element to it, but there are also many other drivers associated to migration. And of course, as we think about policies here, we'll need to basically come up with a real broad policies that are needed and that are listed here. I don't have time to go through them now. Finally, I would say that the last point is to expand global information and early warning system. And here, of course, the development of climate service that try really to provide balanced, credible information, engage users, provide science-based product, improve regional and local prediction is an important aspect, and these climate services are now under development in many parts of the world. And this is my last slide here that shows you that those climate services need to basically use two types of approaches and bring them together. First, a top-down approach dealing with models, with prediction, with downscaling of the model results to the needs of regional and local scale, but at the same time also a bottom-up approach where you look at economic resources, you look at technology infrastructure, institution governance, and you try to develop the adaptive capacity of society and their social vulnerability. And these two communities need to work really clearly together to help basically looking at these aspects, focusing on risk management through increasing community resilience and developing strategy. Thank you very much.
Since Guy has to leave in a few minutes, if there's any important questions, let's get them right now. I can't see over there. Yes. Repeat the question.
That the areas of the world that are most likely to be impacted by drought are also the areas of the world where there's the lowest density of climate observing stations and getting lower. Could you comment on this situation and what might be needed to actually get the world to start making the measurements in these potentially very risky areas?
No, I think you okay, the question is that the regions that are more vulnerable, for example, to droughts, are also the regions where observations are lacking and might even be more lacking in the future. Well, I agree that it is important as we, as a community, develop a global observing system, which, by the way, should not be only a meteorological system, but also a hydrological system, biological system, ecosystem, social system. We need to do that at the international level and including, of course, in particular those nations. What strikes me when I go to these countries is that, in reality, they don't know well enough what those models are predicting as threats and risk for them in the future. What's going to be, you know, the situation in Mexico or in part of Australia or in Spain in the future? So it is important that the governments recognize that this is perhaps the first threat that is beside polar changes, this first threat that is coming, and it is important that monitoring system, climate services be developed in this country. I don't see them coming in this country because that's where the problem will arise, in addition to the polar regions where other issues will be important too.
Are there any other immediate questions? No. I don't see anything. Okay. Thanks, Guy. So John Reisman next will give a short presentation relating to some of the concepts that were important to the Navy talk before then going on to his own talk, and I'll reintroduce him for that. So we switched over.
Wrong one. So as Don mentioned also, the Navy Task Force Climate Change couldn't be here due to budget issues. But I wanted to at least give a presentation. I do not represent the Navy, and what I tried to do is just collect information that they're looking at and how it's going to affect from their perspective, because my goal was to try and bring in military perspective and the intelligence community, which is the next set of slides coming after this one. In 2007, the Center for Naval Analysis started looking at this, and they had a very large group of admirals and economists and climatologists looking at it. And they started to see that it's going to be a serious threat. And this is, all these slides are coming directly from their report, so I don't want to interpret anything. But a serious threat to America's national security, and of course this combined with the WGBU, we start to get a picture of how the security scenario looks from their perspective, and I'm hoping, of course, these communications will help us all understand the situation better. But they also saw it as a threat multiplier, and in other words, exacerbating on top of other threats, and those relate to economic security, socioeconomics, and energy. So there's a lot of different things going on. Of course, the main thing for the Arctic area is the loss of ice volume. And we're starting to see the sea lanes open up, so the Navy is starting to think about, for example, what do we need to do up in the Arctic to protect sea travel for commercial traffic and otherwise. The Maritime Strategy report came out in 2007. A couple of key points there were the effects of climate change may also amplify human suffering through catastrophic storms, loss of arable lands, coastal flooding, could lead to loss of life, involuntary migration, social instability, and regional crises. Climate change is generally opening up the waters of the Arctic not only to new resource development, but also to new shipping routes. That may reshape the global transport system. While these developments offer opportunities for growth, they are potential sources of competition and conflict for access to natural resources. The U.S. Navy Climate Change Roadmap is basically pointing out increased tensions in nations with weak economies, and climate change is affecting and will continue to affect U.S. military installations and access to natural resources worldwide. Of course, sea level rise over time will actually require refitting of certain ports. The Defense Science Board, the point here, this was from October 2011, so very recent. The task force recommends a whole-of-government approach to mitigating the effects of climate change. So they're trying to get a broader scope approach across even the government in America, and of course the same thing's already happening in Europe and across the nations participating with the United Nations. Here we see they're saying they're recognizing that changes are already underway and having and will continue to have major consequences for the political, economic, and geographic world as we know it. So the military perspective is growing in its understanding of what's going on. And the impact on human populations, near and long term, translates to impact on national and international security. One of the interesting things I've seen in multiple reports from joint forces and also from the Center for Strategic and International Studies is not just a whole of government approach, but a whole of governments approach. I believe the CSIS report showed very clearly that if we don't address this together as a world, then we're going to have greater stressors rather than lesser stressors, and that also has shown up in the Army intelligence reports. The effects can be further exacerbated by the nature of human response or lack of response, and that's a very critical point, because the less we respond, then the more stressors we can incur. The challenges associated with climate change generally fall into three categories, and those categories are population support, human security, and political continuity. And we'll go into more about that in the intelligence community reports. The Coast Guard has already requested 8 new national defense cutters just to patrol in the Arctic alone. So, and of course there are a lot of other issues related to this. One of them is disaster assistance and humanitarian aid. And for example, all the military units, especially the naval unit, is looking at, because since they're usually first on scene when we have large-scale disasters such as tsunamis and earthquakes in moving food, they're looking at the stressors incurred on those units as well, with increasing stressors and delivering more aid. So these are economics equations that they're starting to grasp now. Of course, we are losing Arctic ice volume rather rapidly, and I'm ending with this slide because go back to 1988 and you see the red in the picture in your upper left. We're talking about a lot of 5-year plus ice. As of March 2010, the red you see is just a tiny sliver over on the left side of the last slide in the bottom corner on the right hand. So we're losing the ice rather rapidly, and that's doing a lot of dynamical changes with regard to circulation patterns, and of course the traffic is going to increase up there. The strait's been open, I think, some 5 years in a row now. I think it's about that. But there's going to be more traffic, so there are going to be a lot more issues. And that's going to affect possibly different things with the northern amplification effect as well. I'm going to switch over to the other slideshow.
Is this for the other talk?
Yeah. Should we go straight into it, right?
Well, let's reintroduce. Introduce your talk, and then I'll see if I can get it.
Oh, you're on the wrong mouse.
Oh, I'm on the wrong. Never mind. You do it.
Let me try. See if I can get it here. We have several mice up here. They're crawling around. And again, for these reports, what I want to try and do is I'm just going to read off, because really what I wanted to do is just give everybody a feel for what the intelligence community is looking at. And I don't want to really reinterpret anything they're doing. And this goes to, this particular section of the talk has to do with the overview of climate confluence security issues. And this is interesting. This is a CIA report from 1985. And the CIA looks at climate change because it has to do with the capacity of regions and the stressors in those regions, which can alter their socioeconomic stability. This was declassified in actually 1999. One of the interesting things, they already had the definition of greenhouse gases, of course, a gas that traps infrared radiation in the lower atmosphere, causing surface warming. Of course, they looked at all the other gases involved, and so they're pretty much on top of the science. Climate is weather over a longer period. They already had the definition of climate, and of course, even today, there's still confusion between weather and climate. So it's very interesting to see a very good, simple definition for it used in their reporting structures, even back in 1985. This one is interesting because they're talking about climate and technology, and this goes to something Chris Field was also talking about. We don't have as much research going into those areas, and it has to be amplified because there are a lot of stressors that are going to be increasing, and we need to cope with those. Of course, they were looking at grain production back then because the food yield, and this goes again to Chris's talk, the capacity to grow food determines the stability of a region and its capacity to perform. And that, of course, goes to internal and external stressors between nations and intranation. Here they were saying, and again, this is in 1985, and we still hear confusion about climate change today where people are saying things like, well, we don't really know. This is the CIA. Our analysis indicates that precipitation probably will remain near its present level during the rest of the decade. At the same time, we expect temperatures to continue their rise in the grain area because of worldwide increases in atmospheric carbon dioxide. Furthermore, increased temperatures, however, will exacerbate the dry conditions in the southern Urals, lower Volga, and Kazakhstan areas. So in a sense, if you project forward, of course, it goes to soil moisture content. The more we lose the soil moisture content, the more we see the stressors, capacity, and vulnerability to fires, which we, of course, had recently in Russia, which wiped out a tremendous amount of their yield production. Both temperature and precipitation increasing. And this goes, of course, to as we warm the planet, we're seeing, of course, the oceans warm, which evaporates more water, so there's going to be more precipitation, and that will come down again as ice or snow or water. And so in wintertime, we're going to get larger snowstorms, and the rest of the time, we're just getting more hydrologic events and flood events. Here we see part of the long-term temperature increase may reflect urbanization. So they were already calculating the urban heat island effects. And the rest, it says, an increase in air temperature worldwide, the U.S. scientists generally attribute to the atmospheric carbon dioxide. So again, clarifying that this is due to what is already shown in the science way back in the 1980s. And of course, that goes all the way back to the 50s, and we can draw it further back to Svante Arrhenius in 1896 with his early predictions that increasing carbon dioxide would actually keep the planet warmer. Future trends. Our analysis indicates that temperature will continue to increase and precipitation is likely to remain above the long-term average. Again, going to yields and soil moisture, lack of moisture would be the key yield limiting factor. And they say, go over the front part, climate directly affects crop growth and technology inputs, namely fertilizer, because the fertilizer actually needs the moisture to activate. So together, climate and technology are key determinants of grain yields. Now, this is from the CIA World Fact Book, and basically they're looking at the confluence of events. In other words, what are all the stressors? They're talking about overgrazing, deforestation, desertification, loss of wildlife, soil degradation, soil depletion, erosion, and of course global warming becoming a greater concern. The Jet Propulsion Laboratory in 2003, identifying basically the precautionary principle, said there could be extreme or rapid climate shift and we have to examine the stressors. It was this report that actually pushed the climate reporting into the National Intelligence Assessment. So in 2008, they started including the climate assessments into the NIA reports. Global climate change will have wide-ranging implications for U.S. national security interests over the next 20 years. Of course, this is a limited study. They're not looking beyond 20 in this report. They do have 30-year reports, and they're looking beyond as they continue their work. Through 2025, the already stressed resource sector will be further complicated and, in most cases, exacerbated by climate change, whose physical effects will worsen throughout this period. Continued escalation of energy demand will hasten the impacts of climate change. Climatically, rainfall anomalies and constricted seasonal flows of snow and glacial melts are aggravating water scarcities, harming agriculture in many parts of the globe. Energy and climate dynamics also combine to amplify a number of other ills, such as health problems, agricultural losses to pests, and storm damage. The greatest danger may arise from the convergence of interaction of many stresses simultaneously. Such a complex and unprecedented syndrome of problems could cause outright state failure or weaken important pivotal states counted on to act as anchors of regional stability. Now, from 2011, rapidly changing environmental conditions, large-scale shifts or increases in hydrological variability, political shifts and/or unilateral development increase the likelihood of conflict over shared water within a basin. From the Office of Secretary of Defense, develop their plans and objectives to develop strategies to manage rising worldwide tensions as a result of global warming, threats that include a mix of traditional and irregular forms of conflict, and the problem of weak and failing states. That's it. Thank you.
Okay, so have Chris and John come back up here, and we can address additional questions and concerns and comments from the audience. I don't know if we, unfortunately, I don't think we have an extra microphone today, so please be as loud as you can, and we'll try to make sure that your question is repeated up here. So, anyone with, yes, right here.
Speak a little bit louder.
I don't know if you're going to be able to answer this, and I will say, for me, this is the first time I've been made aware of the intelligence and defense community's assessment and reporting on climate change, but I'm wondering if you can speak at all to, given their assessment and the understanding that this reporting shows of the complexities and realities of these issues, why are we having politically such difficulty in formulating any policy responses that are based on the science?
So the question basically is, given that DOD is already putting essentially actions into place, why is it politically our country is having trouble trying to do anything about climate change?
Okay. Of course, there are two separate issues, and I can't speak for the DOD, of course, or the intelligence community, but they are aware. We can see that. This is directly from their reports, and these reports now come out annually. The problem between that, we're looking at a cultural distinction between what the government knows at certain levels versus the political knowledge or understanding of it based on constituency bases. For example, if a politician's constituency doesn't understand it, that influences often a politician's position on what he's going to speak about or what he's going to believe. It's an unfortunate reality. It doesn't happen in all cases. There are many politicians that actually are taking a stance on it and saying, you know, this is real, this is happening, this is what the science says, we can see it, it's in the evidence, it's in the observations. The real issue, I think, regarding your question has to do with what's called cognitive dissonance, which is the confusion factor of people, because they still get confused about the difference between weather and climate. There are so many factors and there's so many complications, and there are special interests involved trying to divert attention from different areas. So in that case, the confusion level is still high. We need to communicate better what the relevance issues are, why climate change happens, what are the effects now, and how to separate, for example, something as simple as climate and weather even from the CIA's definition. Weather is climate over a longer period, or climate is weather over a longer period. So it's just the trends, and that, of course, we know is related to the radiative forcing increase.
Did you want to mention your book? Okay, there's a question back there. Okay, thank you. So basically the comment is that, we could do, in terms of communication of climate change, the scientists could do a better job in citing all these different reports and make sure they're out there. I know I personally give many public talks on climate change and do that. And always start my talks out saying within the community there is no debate. And people are shocked because they see all this stuff about debate in the media. And unfortunately, I don't want to call them skeptics, I don't want to call them denialists, I'll call them confusionists, because I think it's a lot of the plan that is really aimed at trying to make sure the public is confused about this and that they think there's a debate. I want to let John respond to this, and I don't know if did you want to say something too?
I might just say one thing about the bringing security into the public dialogue. It's a really important point in the next round of the IPCC reports, the ones that will be released in 2013 and 2014, really casting the issues in the security context. And in particular, there'll be a new chapter on climate change and security, something the IPCC has never taken on before. You can argue about how effective the communications from the IPCC are, but I think it's clearly making its way into the dialogue and the way that the scientific community presents where we are with understanding climate change.
Yeah. On a couple of points, I will put these NIA reports. I have a website called the OSS Foundation. It's just ossfoundation.us. And I'll put the NIA reports up there so they can be downloaded and quoted, and you can use them as you need them. So that I already have a good collection of security reports up there already, and there are different analyses that you can look up and download reports for. Also, I have a book out it's currently in paperback, hopefully in hardback soon, but it's called Exposing the Climate Hoax. So it's a very direct approach to saying, look, there actually is a hoax. It's just not the hoax that's being propagated on one side. It's funny because Roger Pielke Sr. actually testified in Congress that there's an oligarchy of scientists trying to trick us or control the message, if you will. I don't remember his exact phrasing, but it was interesting that if you look up the definition of oligarchy, it means a small number of people. And it's hard to say that hundreds of institutions and thousands of scientists are an oligarchy, when in fact it seems there are only about maybe a handful of scientists that are still confusing us on the message that might actually constitute that oligarchy. And I detail that very clearly in the book.
Yes, right here. Okay, so the question has to do with regime shifts and how do we, if we're going to likely pass 450 parts per million of CO2 in the coming decades, does that mean we really need to look at policy differently than we have been, even in terms of what we're suggesting to do about climate? So, Chris?
It's a great question. You know, when we think about approaches to climate, a useful starting point is Article 2 of the UN Framework Convention, where it says our goal is to avoid dangerous anthropogenic interference in the climate system. The question is 2C as a global average dangerous anthropogenic interference? Have we already passed dangerous anthropogenic interference in some parts of the world? Are there some parts that are resilient up to changes of 3, 4, even more? And a really interesting part of the same paragraph in Article 2 says to ensure that ecosystems and agriculture can adjust as the pace of climate changes, and also to ensure sustainable economic development. And I think that if you take a generous view of the climate debates, most of the debate has been about is the question of sustaining economic development, mainly about not diverting so much from economic development that we harm economic growth, or is it mainly about protecting climatic conditions such that sustainable economic development can continue. I think that's a legitimate debate. But I also think that we moved into general agreement, not including the U.S., but much of the world, that a 2-degree target was an appropriate one on grounds that had some scientific input, but had a lot of political input. And it is a very useful number to rally around. I think the scientific foundation that a lot of the thresholds that I talked about and other ones really occur close to 2 degrees is very far from clear. But from a risk management perspective, we can say the following. We know that the more it warms, the more we run the risk of crossing one of these very dangerous thresholds. We know that as we warm more and more, and particularly commit to more and more infrastructure for future fossil emissions, the more expensive and the more difficult it is to back off of those emissions. And we also know that as we delay action, the more impacts we bake into the system and are not going to be able to avoid. Unfortunately, I think there is a very destructive trend in the dialogue at this point that says, well, if we're going to miss a 450 target or if we're going to miss a 2-degree target, the problem is not worth addressing. And that's exactly the wrong way to think about it. If we should miss a 2-degree target, what it means is that the target, that it becomes even more important to act, it becomes more expensive, it becomes more difficult, and the residual impacts become greater. And I think that the reason people ought to be serious about mobilizing toward particular targets, and I think 2 was a perfectly good one, is that it's very useful to have a target in mind. But the thing you need to understand in the background is that missing the target just means you have to work harder in the future. It doesn't mean that somehow the problem either becomes totally unmanageable or goes away. And that's, we tend to think about the problem with those 2 extremes, neither of which is right.
All right. The mouse has a tail. Just to add to that point, it's interesting, when we look at the 2C target, I like to explain to people to think about it like a speeding ticket. And for every, say, 0.1 you go past 2C, the ticket gets more expensive. And for every 0.1 below 2 Celsius, then it gets less expensive. But in this case, it's an exponential change with regard to impacts globally, as we've seen through several presentations here regarding security impacts. So if you go to 2.1, it's going to be that much more expensive. And you go to 2.2, it's going to be that much more, or 2.3 and even higher, because there's inertia involved here. CO2 has a massive inertia. And it's kind of crazy to bring up what it really means in zettajoules, but 1.66, which is the AR4 report of increased radiative forcing, adds up to 26 zettajoules. And the recent, and that's the per year amount, that's the actual per year amount. When you look at NASA's most recent analysis, it's at 1.8, and that puts us now at 29 zettajoules per year. So this speeding ticket's going to get really expensive. So we don't want to go past that too far if we can help it.
Okay, next question. Okay, thanks, Chuck. I can't see you. The lights shine right in my eyes.
ExxonMobil came out yesterday with their annual energy forecast for the world. They forecast over the next 30 years that U.S., Europe, and similar countries will be approximately flat level of their current energy use levels, and that China and India will increase 60% over the next 30 years. I think it's a fair assumption that most of that will be in fossil energy, so that there will be a very substantial increase, not a decrease, in CO2 emissions globally over the next 30 years. Given that likelihood, I think it's a very strong likelihood, I think it becomes all the more important to look at adaptation to something that's probably not going to be preventable. But the IPCC in the past, at least, has said very little about adaptation. I wanted to ask Chris, is that going to change in the next IPCC report? Far more discussion of adaptation.
Okay, so the question deals with the fact that Exxon just came out with an evaluation of future energy needs and suggests that there'll be a 60% increase in Asian, or in energy use in Asia, most of which will likely be fossil fuel, therefore further extending the concerns about climate. And as a result, is IPCC putting more emphasis into adaptation in its assessments. And I'll let Chris deal with that.
That's a great question. I want to comment on two aspects. The first part about the trajectory for increased emissions, especially from India and China. I think that those projections don't have to be the way the world turns out, and I think that this is a problem that, if it received dedicated attention from the world's communities, really could see us make a transition toward a much lower emissions future on a timetable that falls well within that 30 years. But it is the case that if you said what's the most likely outcome now, we would see dramatic increases in emissions in the future, and I think that we should be looking at a wide range of options, including adaptation options. I'm going to get to adaptation in a second. But I think we also ought to be looking hard at technologies to remove CO2 from the atmosphere. So in response to your question about adaptation, it's a great question. We just released a special report on managing the risks of extreme events and disasters 3 weeks ago in Kampala. That report has 9 chapters. 3 of the 9 are explicitly focused on adaptation. Only 1 is focused on the physical climate science. It's the first IPCC report ever to represent a joint effort of Working Group 2, which deals with the impacts, adaptation, and vulnerability, and Working Group 1 together. Working Group 1 deals with the physical climate aspects. And I think that within the Working Group 2 community, it's very clear that we need to put a priority on adaptation in the AR5 report, the one for which we have our second lead author meeting next week. There'll be 4 chapters on adaptation, and only 1 in the past. So it's getting to be a much bigger part of the portfolio, but there's no sense in which this focus on adaptation says that we need to be less serious about mitigation. It's an acknowledgement of what the world is like that we live in, and a recognition that we've really baked a lot of climate change into the system, and that there are going to be impacts of that. And especially in the short term, the main tools we're going to have to deal with those are going to be tools that are based on adaptation, with mitigation becoming more and more important in the longer run. The other thing that is an acute focus in the AR5 is the idea that adaptation, mitigation, and sustainable development really can't be separated, and that they need to be conceptualized, designed, and implemented as an integrated set of activities.
Yes, way back there, yes.
My question is, for people who are trying to plan in terms of national security and food security, how do they deal with the uncertainties involved, what emissions are going to be, and then the subsequent uncertainties in the climate projections?
Okay. For people trying to, so the question is, what for people trying to plan in terms of both national and food security, how do they deal with the uncertainties associated with those analyses? Somebody want to take that on, Chris?
So, that's a really good question. It's probably the most important question that we face in trying to come up with smart responses to climate change. And it's frustrating for me because we, civilization, is really good at making decisions under uncertainty, and in most situations. We make decisions under uncertainty when we decide whether to buy insurance for our house. We make decisions under uncertainty when we decide whether to wear a seatbelt. We make decisions under uncertainty when we decide whether to invest in a new home or on remodeling or in any other kind of financial activity. And in general, the kinds of tools we have are the kinds of tools that risk managers would say you should have. You should be averse to risk. You should have a diversified portfolio. You should make sure that you can afford whatever it is you do. And those kinds of simple rules could very effectively be applied to the climate problem, but I don't see us doing that. And I think that a lot of the reason for that is that the climate problem hasn't in the past typically been framed as a problem in decision-making under uncertainty. It's been framed as a problem, well, once the science 100% sure, then we'll know what to do. And we're making a lot of progress in the science, but we're not going to be at the situation where we have 100% certainty ever. The fundamental problem is like the problem of decision-making under an uncertainty that we face in all those other aspects of our daily lives.
Did you want to say anything, John? Okay, yeah, I agree. That's the right approach. Any further questions? Yes, right here. I'm right under the lights and I can't see you. Okay, so the question relates to having Chris expand upon a statement about the need for more studies on how to remove CO2 from the atmosphere, but also the question about geoengineering and you know, the outlook on that. So, Chris, you want to start, and then John?
So, so the question is, where are we in thinking about geoengineering in the IPCC, and why did I personally say I think we ought to be looking at technologies to remove CO2 from the atmosphere? You know, as of the 2007 report, the AIR4, the IPCC didn't really say anything about geoengineering, and it has really only come under the international scientific and policy spotlight in the last couple of years. Geoengineering, as you probably all know, kind of falls into two broad categories. There's one category that's often called carbon dioxide removal, techniques that range from ocean fertilization, growing more forests, geological carbon capture and storage, ways to take CO2 out of the atmosphere and put it into long-term reserves. Those tend to be, they tend to be very local. They tend to be things that are reversing the climate change forcings and are relatively easy to modulate. The other class of geoengineering options is often called solar radiation management, and that's typically intended as ways to reflect some of the incoming solar radiation either outside the atmosphere or high in the atmosphere or sometimes even at the surface. Those are techniques that tend to have a lot more leverage on the system, where a lot smaller tweaks can potentially have bigger results, and where instead of removing the forcing of climate change, we're introducing another alteration into the system. The IPCC is committed to providing an assessment of the full range of geoengineering options, and we had an expert meeting on geoengineering, including both solar radiation management and carbon dioxide removal, earlier this year in Peru. And the assessment from the IPCC is not yet complete, but let me just say that personally, my feeling is that there's a huge contrast where the risk elements that are associated with solar radiation management are quite profound and quite troubling, where the risk elements that are associated with carbon dioxide removal are much less of a concern and in fact represent an additional mechanism for backing away from climate forcing. The reason I said I think we ought to be studying approaches to remove CO2 from the atmosphere is not based on an IPCC assessment. IPCC hasn't really looked at this yet, except in the special report on carbon capture and storage, which is one subset of the geoengineering approaches. But the reason I say it is that I think that we are looking at rapidly increasing emissions. I'm sure everybody saw the news that said we had the biggest one-year-on-year increase in emissions ever, going from 2009 to 2010. And I think we face profound political challenges in getting emissions increases under control, and I think that if we're going to be responsible in the scientific community, we ought to be able to provide as much information as possible on the full range of possible solutions, and that includes mitigation solutions, technologies for decreasing CO2 emissions, includes adaptation solutions, ways to cope with the climate change that can't be avoided. But I think it also should look at whether or not there's a possibility to actually remove the CO2 from the atmosphere and back off on the climate, because one of the most disturbing recent results, it's been confirmed in a number of studies now, is that once we produce a certain amount of warming as a result of increased CO2, that warming stays in the system on the millennial time scale. As the CO2 concentration even backs off through natural uptake by the ocean, the warming essentially stays in place. So I think this permanence really, at least for me, provides kind of the final zipper on the idea that we ought to be looking at the broadest range of possible technologies, and that needs to include carbon dioxide removal without, from my perspective, any prejudgment on what kinds of technologies might work and what might not. But at least we want to go into this having the best scientific foundation. Doug, you want to comment further?
I was going to say something.
Oh, good.
I'm a coordinating lead author on the working group 1 of the science part of the IPCC assessment, and I was at the meeting in Lima that Chris just mentioned on downscale on looking at geoengineering. And in this assessment, in working group 1, there will be a discussion of geoengineering. It's not going to go into great depth because we don't have great depth of knowledge, but raise the issue and to look at what is understood and what some of these potential risks are, suggesting that we need further research. So are there further questions or comments? Right here. So the question is asking if John can comment further on what other countries are thinking about security in relationship to climate change. Yeah, make a comment, John?
The WGBU report that came from Germany was really quite profound. So that's already encapsulating a very strong perspective from a security analysis, and they're looking very holistically at the problem. But I think it's also important to look at the IPCC reports, the AR4, of course, the AR5 is coming up in 2014. All of this is security, and all of this is economics. And that has to actually be tied in with our energy reality as well, because we have to transition the energy economy. So whenever they talk about changes, whenever they talk about hydrologics, when they talk about soil moisture content, those are security issues. That is already the world's, the governments and the educational institutions and research organizations, all of this is security. So in a sense, it's one of the reasons why I wanted to do this particular talk today, is because I want everyone to reframe the message. Let's talk about what our security means. It means economic capacity and stability, relatively speaking, because these things are changing. And when we talk about food yields and soil moisture content, floods that can actually wipe out a whole set of crops, or fires and droughts, we're talking about our complete security. So the intelligence community is a piece of the puzzle, and that shows that from stability and state failure concepts, how they look at it based on the IPCC mean. So they're looking at the mean of the analysis and what that translates to. But every time the world talks about, food production and crop yield, we're talking about international security. That's really what it comes down to.
Okay. Any others? I don't see anyone else. Shall we thank the speakers one more time, please? And then and thank you all for coming.